Hi, everyone. Welcome to the first session of our discussion on Module 3. And we'll start with the time value of money. The basics, we'll go through those and then tie them to the investment decisions and then move on from there. So we'll start with Chapter 5, Time Value of Money. First of all, we'll learn how to calculate the future value of money, present value and future value, how to move between today and tomorrow, how to calculate today's dollars and tomorrow's dollars, how to switch between the two. We'll talk about the present and future value of level stream of cash payments, same. And then we'll talk about multiple streams, we'll talk about interest rates, we'll talk about nominal and real cash flows and all the fun things. So we'll start with all these things. And the first thing is we start with today's dollar. So as we all know, today's dollar and tomorrow's dollar are two different things. And there is a bridge connecting them. And the bridge is the interest rate and the compound interest formula. Future value is tomorrow's dollar. So we know that today's dollar is stronger than tomorrow's dollar, given in a world with inflation and interest rates and all those things. We know that today's dollar is stronger than tomorrow's dollar. So if we get the same amount of money today versus tomorrow, they are not really the same. Today's is more than tomorrow's. If I get $100 today versus $100 tomorrow, today's dollar is more. And we'll see how they are related. The link between them is the interest rate. And there are two kinds of interest rates, simple and compound. And in simple interest, we earn the interest always on the original investment. So we don't increase the amount every year. Supposing I put in $100 and put it on simple interest for 2 years. Each year I will earn, and let's say 10% is the interest rate, then each year I will earn $10 on the original investment, $100. But in compound interest, what happens is I earn the interest on the interest that I get every year also. So the interest is also compounded. So first year I get $10 as interest. Then second year, I'll get 10% more of that. So that means my initial startup will be $110. $110, and then I get 10% of that. So my interest keeps growing on that. That is the difference between the two. And if we connect the two, actually before I go into all these things, let me do a new share here and start with a whiteboard. Share. And let's say here we have today's dollar. So if I put $100 today, or $1 today, today. This is now, N-O-W, now. And this is year one. And let's say the bridge between now and year one is the interest rate, R. Let us say that interest rate is 10% I'm just exaggerating it. It's not like that, but 10%. Then, the link between the two is obviously this is present value, now is present value. Value. And this is future value. So the link between them is the interest rate. And how are they related? Future value will be present value, that is today's dollar, times 1 plus R to the power T, right? So if this is, I'm just putting here T over here. So this compound interest formula over here that you're seeing, this is the link. And if I want to go from a future dollar to today, then what do I have to do? I have to take this future value, this equals. So to move from future value to present value, I come here and I take future value and divide it by 1 plus R to the power T. So here, what I call this part is the future value factor, FV factor. 1 plus R to the power T is the future value factor. And 1 divided by 1, this is 1 divided times 1. 1 divided by 1 plus R to the power T, this discount. This is called the present value factor or the discount factor. Present value factor, also called the discount factor. Okay. So this is the link. This compound interest formula is the link from moving between today's dollar and tomorrow's dollar. It's very simple. This 1 plus R to the power T is the link. This is the future value factor. So if I have got, for example, if I have got, this is again. So if I have, say, $100 just now, and my interest rate is 10%, and at the end of 1 year, T equals 1, this becomes $110. This 1 plus R to the power T times $100, it becomes $110. 1.1 to the power 1 times $100 is $110. If it is 2 years, it will be squared. If it is 3 years, it will be cubed, like that. And if I want to convert the $110 from tomorrow and bring it to today's dollar, then I discount 1 divided by 1 plus R to the power T. This is called the discount factor. R is the discount rate, or whatever you want to call it. This is the interest rate. But discount factor, 1 divided by 1 plus R to the power T, that is the discount factor. That is the bridge between today's and tomorrow's dollar. So with that, we are back to our PowerPoint. So here is an example. I start with a simple interest and move to compound interest. Okay. If you can see my slide, just give me a thumbs up. Okay, thanks. So now, simple interest, let us say I earn 6% interest for 5 years on a principal balance of $10,000. So I do my interest per year, because the interest, simple interest is on the, it is on what? On the original balance, the initial balance. That's it. So 6% times 10,000 is $600. And for 5 years, I multiply that interest. So it's $3,000 is my interest. So my future value will be $10,000 plus $3,000 interest is $13,000. It looks very simple, but in real world, in the banks and all, it's very seldom seen. You know, but this is the seed. This is the basic concept, and everything builds on top of this. In fact, it is so nice that this bridge that we discussed, present value and future value, this constitutes the foundation of investment decisions, investment and financing decisions. This is a very, very fundamental concept, and it comes everywhere. It comes handy everywhere. This is the foundation of finance, present value, future value. So it's very important to understand it properly, because this is how we value anything. Whether you are valuing your company's, your firm's value, whether you're valuing a stock's price, whether you're valuing a bond, everything is like that. It's all, it depends upon this, your understanding of this concept. So the interest is earned only on the original investment for this simple interest. Now, let's go to compound interest. Now, in compound interest, if you invest $100 at 6% and compounded, this is compounded annually for 5 years, then what happens? See how we calculate it. Okay. So we start just now with $100. Then next year, it becomes, by the end of year one, period one, it becomes $106, 6% interest. Look, this is the future value factor, 1 plus r to the power t. My t is 1. So r is 6%, 6%, the original 6%. This is the r. This will stay throughout. Okay. So 1.06 to the power 1 times 100 is 106. And I square it, I cube it to the power 4 to the power 5 at the end of every year. So next year, I start earning interest on $106. So now my total interest, my total value becomes $112.36. Then the third year, I start earning interest on $112.36. So now my total value becomes $119. This is the most important thing, this compound interest. It will grow exponentially. So it starts growing every year. And so at the end of year 5, it becomes $133.82. This is the value of $100. Got it? So we come to what we started with. Future value equals 1 plus r to the power t times present value, today's dollar. Tomorrow's dollar equals today's dollar times 1 plus r to the power t. This is the magic wand in finance. And this is actually, as I said, it is at the base of everything. Whether you're talking of, when you're valuing a company, you're valuing its stream of future earnings and converting them to today's dollars. That's what you're doing. Do you understand? So it's at the base of everything. Here is an example. Okay. Future value using this formula. How much will you accumulate if you invest $100 at 10% interest amount quarterly for 3 years? Notice here, I have put in a change here. The 10% interest amount is compounded quarterly for 3 years, not annually. My interest that is given here is annual. this is customary. When we say interest and we don't specify it is quarterly interest or monthly interest, that means it is annual interest. So here we have to be consistent. So when I'm talking of quarters in terms of time, then 3 years is 3 times 4, that is 12 quarters. And this interest is compounded quarterly. So this interest is annual, 10% is annual. Now I can't take 10% annual interest and apply it to quarters. I have to divide it into quarters. So 10 divided by 4, that is my quarterly interest. 2.5% is my quarterly interest. And now we are in business here. So here present value is $100. My quarterly interest rate is 10 divided by 4, that's 2.5% or 0.025. And my quarters, the time, number of periods is 3 times 4 equals 12 periods. So my future value is present value times 1 plus r to the power t, 1 plus 0.025 to the power 12, that becomes $134.49. A little bit more than annual, right? Recall the annual was 133.82. Now this was a different example. Actually, this is 5 years, a different example. Let's not compare those. But here, again, we use, quarterly interest with quarterly compounding. Annual interest with annual compounding. First lesson to understand here. So coming back to the concept of present value, as I explained earlier, we have to discount the future value by 1 plus r to the power t. So this here, r is the discount rate. So don't get confused when people say interest rate and discount rate. You're discounting future to present, that's why it's called a discount rate. But it is the interest rate. It is the same thing. But when I'm talking of 1 divided by 1 plus r to the power t, this whole thing is the discount factor. So please understand the difference between the two. Okay. So note here, as the r or t increases, r or the discount rate or the time period increases, what happens? The denominator over here will increase, so the present value will go down. So it lowers as r or t increase, the discount factor decreases because the denominator increases. Discount factor goes down. And lower the discount rate, higher the present value because the denominator will be low. Higher the discount rate, lower will be the present value. So this is this relationship you have to understand. Okay. More the discount rate, the denominator will be more. You're discounting more. Higher the discount rate, you're discounting more. So your present value will be less. Lower the discount rate, you're discounting less. So your present value will be more. And same thing with T. You can go up and down the same way. Now, the beauty is that this discount factor is available everywhere, readily available. People make things simple for you. So it is readily available everywhere. They calculate. What does this mean? If I say the discount factor is 1 divided by 1 plus r to the power t, simply means this is the present value of $1, now numerator, $1 received after t time periods. So that's what we call discount factor. And if it was 1 plus r to the power t, that is a future value of $1, the future value factor. So future value of $1 tomorrow, 1 times 1 plus r to the power t. So these tables, excuse me, where are we? So these tables are readily available. Here is an example. I'll show you. Give me a second. Can you see the table? Okay.
No.
The table here. Can you see the table? No. Okay. So I go here and I come here and I go share. Can you see the table now? Yeah. So this present value table and future value table. Simply present value factor. It gives you the present value factor and the future value factor. So here it simply tells you, for example, the interest rate goes across and the number of years comes down here. Okay. So the interest rate is 5%. Okay. And let's say you receive, number of years after 1 year. If you receive $1 at the end of 1 year at 5% interest rate, the interest rate is 5%, what is it worth today? So 1 divided by 1 plus r to the power 1, 1.05 to the power 1 is 0.9524. So they have made it easier for you. They have calculated it. You can read it off the table. If you want to know what is the present value of $1 received after 10 years, and let us say the interest rate is 10%. So you go 10 years and go across 10%. And so if you receive $1 after 10 years and the interest rate on an average was 10%, then it is 0.3855. Today it is just worth 38.55 cents. That's it. So that is the meaning of present value table. So all you need to do is, if you have a stream of cash flows in the present, you just have to multiply with the present value factor and you can get the present value of the total amount. It's easy, makes it convenient for you. Same thing with future value table. Future value table, if you go down, it's like this. What does it tell you? Future value of $1 received after n years, period is, and the interest rate is I. So here, for example, 6% is the interest rate, and 12 years, after 12 years, you receive $1 and the interest rate was 6%. Today, it is just worth $2. No, this is the future value. So what is the future value of $1? Future value of $1 if the interest rate is 6% and the time period is 12. That means what is $1 today worth after 12 years if the interest rate was 6%? It is worth $2.0122. That's it. Okay. So this will grow. As the I grows, interest rate grows, the value grows. As the number of years go, you'll see that the value grows. So that's how it works. You can read it off and multiply the cash flow and you'll get the future value. So that's how you read the tables. I'm back to our slides here. Can you see the slides? Thank you. So now, again, going step by step. Example, discount factor. What is the discount factor for $1 to be received in 5 years at a discount rate of 8%? Discount rate, remember, discount rate is R and discount factor is what we want to know. So what is the discount factor for $1 to be received in 5 years at a discount rate of 8%? So 1 divided by 1 plus r to the power t, 1 divided by 0.08, this will be 0.08. 8% is This is 80%. This should be 0.08. Please correct it. So 0.08 to the power 5. And that should be equal to 0.6806. So in other words, it simply means that if you get $1 after 5 years and the average interest rate was 8%, then today it is worth only 68 cents. This is what it means. Okay. So we move on to another example here. Discount factor here. In calculating the present value of $1,000 to be received in 5 years from today, the discount factor has been calculated to be 0.7008. What is the apparent interest rate? What is the apparent interest rate? So if the discount factor has been calculated as 1 divided by 1 plus r to the power 5 is 0.7008, you can easily find out the apparent interest rate, So over here, 1 plus r, if you solve for this, then 1 plus r will be, you get this amount and r will be equal to 7.37% interest rate. But the beauty of all this is when you use Excel, you can find out all these things very easily. And, I'll show you those things too. Let's look at the timeline now. Over a time period, how to look it in a picture form. Timeline, if you draw it, helps you to calculate the present value. So in our book, they have talked about the kangaroo autos, and they say that, your cash flows are distributed as follows. Just now, it is $8,000, and then at the end of year 2, you're getting $12,000. So, and the interest rate over here is 10%. So, what is the present value of that today? So here you're getting $12,000 at the end of year 2, and the interest rate is 10%. So my discount factor becomes 1 divided by 1.1 to the power 2. So I multiply 12,000, or I divide 12,000 by 1.1 to the power 2, and I get the present value of this $12,000 actually today is $9,917.36. So if I add them all up, my total value is $17,917.36. That is what it is worth today. You don't just add 8 and 12 and say $20,000. No. Today's dollar, tomorrow's dollar is an orange, today's dollar is an apple. The orange has to be converted to an apple, so we are just adding the apples. So here we have $17,917.36 is the present value of this cash flow. Remember here, so you have a stream of cash flows. Another example over here. $8,000 you get just now, $4,000 you get after year 1, and $4,000 you get in year 2, at the end of year 2. What is the present value of these? And if the interest rate is 8%, then what is the present value of these? So what is best to do here is you discount $4,000 by 1.08 to the power 1. So that is discounted here, 4,000 divided by 1.08 to the power 1. That is equal to $3,703.70. That is the present value of this 4,000 received in year 1. What is the present value of 4,000 received in year 2? 4,000 divided by 1.08 to the power 2. So that is equal to $3,429.36 today. Now, all these over here, all these here, they are all apples. So we can add them. They are not tomorrow's dollars, they are today's dollars. All here. So we add them up. And when we add them, the present value of this stream of cash flows is $15,133.06. Today, it is worth that much. Once again, you're not going to add 4, 4, and 8 and say, okay, 8 and 8, 16, so it is worth 16,000. No. That is being realistic now. You are converting tomorrow's dollar to today's dollar and then adding them. So that is the present value of cash flow concept. Remember here that the cash flows that are occurring in different periods should not be compared unless they have been discounted to a common date. And that is 0, time 0. Now we are comparing. Moving along with this present value concept, let's look at another example. I'm sorry. Your auto dealer gives you the choice to pay $15,500 cash just now, or make 3 payments of $8,000 now, $4,000 at the end of the following 2 years, the cash flow that we were looking at. If your cost of money is $8,000, what do you prefer? Notice the example that we are doing earlier. Now we are applying it here. Okay, so my options are either I pay 15,500 now, or I pay 8,000 now, 4,000 year 1, 4,000 year 2. Okay, you have the answer in front of you because we've done it already here in the stream of cash flows. To total, if the present value of this option, 8,000 now, 4,000 year 1, 4,000 year 2, the present value of that is $15,133 as opposed to $15,500. Obviously, I will choose $15,133 to pay, and that gives me the option to spread out my payments also. Okay. So this is, and you can do this in Excel. So, and how to use the present value and future value formulas. I will explain it to you once I am doing, stream of cash flows and all those things. I'll explain it to you comprehensively, one shot. Okay. So here, or let me explain it right now. That will be better. So I take this example. My screen sharing has stopped, it says. Screen share again. Come back to my share. Can you see the PowerPoint? Okay. Now what I'm going to do is scroll down to the auto example. The auto example, this example. Copy. Now I'm going to paste it. New share. Can you see the spreadsheet? So I'm just pasting it here. So my cash flows are time 0, 8,000 times 1, 4,000 times 2, 4,000. Okay. How do I get the present value of these cash flows? One way to do it is do it mathematically. So I will show you how to do it mathematically. What I'm going to do now is I'm going to explain it to you in a different way. I'm going to put this now. Copy the cash flows. And paste values. No, paste it like this. Yeah. What happened? Paste it like this. Yeah. So my time periods are horizontal and my cash flow is also horizontal. So now, what is my interest rate? R, discount rate or the interest rate is 8%, 0.08. All right. So first thing is this is the safest way to do. You will never go wrong here. If you think that your formulas are not working, then you will never go wrong if you do it this way because you know the basics. So my discount factor or the present value factor is what? Equals 1 divided by 1 plus R, 1, so I'm going to double parenthesis, 1 plus R, R is my 0.08, and I'm going to fix this cell so it doesn't change, dollar, dollar. To the power is this, and T, time period, this cell here. And I close this. Notice, what will it become? Anything to the power 0 becomes 1. So 1 divided by 1 is 1. So simply means that today's dollar, $1 received today means $1 in present value is $1. Right? Now, if I copy this across the same formula, because time period 1, time period 2, notice my present value factors, I don't even need to look at a table, I generate it right here for you. It simply means that if I receive $1 at the end of 1 year and the interest rate is 8%, then it is worth 92 cents just now, present value. At the end of 2 years, if I get that $1, it is worth 85 cents just now. Got it? So I want to do the present value of the cash flows. So I do present value. I'm going to expand it for you. So the present value of cash flows, what is this? It is the product of today's factor times the cash flow. The present value factors times the cash flow equals this cash flow times the present value factor, which is here. So I multiply it and I get the present value of cash flows like this. Got it? And then my total sum of this cash flow, total present value of total cash flows is what? Sum of all this just now equals sum of all this. $15,133.06. Notice is the same number. $15,133.06. This is one way of approaching it. Another way of approaching this is to use the present value formula as they have shown in the slide. Present value. What is the interest rate? What is the time period? Right? So the best way for those of you who are not so familiar with this option is to look at, so using present value formula. How will you do it? So let's look at the present value formula. Formula, I click the formula button here on top. See? So automatically there are so many different kinds of formulas here. So I'm looking at financial formulas. Financial, I click here. And then I will see the present value, PV formula. MNOP, PV formula. And notice, can you see the box that popped up? Can you see the box here that I'm showing? You can, yeah, okay. So my rate, what is my rate? My rate is 8%. So I click this box, C9. If you want to fix it, you can, you don't need to fix it. I'm just doing the box here. What is the time period? My time period over here is how much? 3 years, 2 years, what is it? 2 years? See, I'm getting year 1, 8,000, year 0, 8,000, and I'm getting this and this. Now, remember, whenever you use the present value formula, it will always spit a negative number for you because it will think it is a payment. So I am taking the present value of 2. There are 2 future cash flows over here, this and this, right? So my time period over here, when I'm saying, give me a second here, present value. All right, let me go consistent with your book. Oh, let's just explain it like that. So equals present value, and my rate is 8%, and my payment is 4,000 for 2 years. My MPER is 2 years. 2 years is the time period. 2 future time periods, 1 and 2. So 2 future time periods. And my payment is what? $4,000? Payment, how much payment are you making? $4,000 you're getting, right? This is annuity actually, and explain annuity to you. So it's once again, let me get this first, then I'll show you how to use the box again. So it is the payment is $4,000, good. So this, and then I'll do minus my initial amount of $8,000, right? So notice over here is $15,133.06. What did I do? Once again, there were 2 future values, year 1 and year 2, right? So what did I do here? I took the present value formula. I'll delete it again, do it again for you. I'll use the formula function, use the financial function, go to present value, MNOP, PV. What is my interest rate? Interest rate is 8%. How many years? 2 years, because 1 year and year 1 and year 2. What is the payment I am receiving consistently every year? $4,000. So I can pick any one, any cell, but I'm picking one, $4,000. Okay. And this is the present value of 2 years of cash flow, 4,000 and 4,000. Okay. Then what do? I add today's cash flow, but it is all a negative number, right? So I subtract it because it takes it as a cash flow outflow. So I subtract it. So that is minus 15,100, that is $15,133.06 is the payment, is the amount worth investing today. But the problem is here, it is inherent in the formula of Excel. All the present value formulas will spit out negative numbers to you. Other way of doing it, if you just want to add the $8,000, then you show your cash flows. If you want to add the $8,000, then you show the cash flows here, the present value as a negative number, and you will get the same answer, positive, $15,133.06. So both ways you're okay. So this is how we do it in Excel. And I will go back to the PowerPoint slides. Go back to the PowerPoint slides and continue from here. Can you see the slides now? The PowerPoint? Thank you. So now we have, this is how to do it on a spreadsheet. I showed it to you. Now we move on to some terms. The 4,000 consistent payment that you are getting each year is called an annuity for 2 years, because it is limited to 2 years time period or a fixed time period. So what is an annuity? An annuity is equal stream of cash flows at regular intervals with a finite maturity. So when you get the cash flows for a fixed number of years, that is called an annuity. And if you get the cash flow, the same fixed cash flow that never ends, it lasts forever, that is called a perpetuity. So remember, in annuity, the T is finite. In perpetuity, the T is infinity. You just use infinity over there. It's for unlimited number of years. So to calculate the present value of cash flow of a perpetuity, infinite stream of cash flows, if you get C dollars infinite for infinite number of years, then you just discount it by the interest rate. You don't have to go to a T. You understand? And you can solve it mathematically, and you see that that formula condenses to an R. So it is present value of a perpetuity is C divided by R. The cash flows divided, the fixed stream of cash flows divided by the interest rate or the discount rate, whatever you want to call it. And if you want to convert it to an annuity for a fixed number of years, well, okay, let's do an example for a perpetuity over here. In order to create an endowment which pays $100,000 per year forever, how much money must be set aside today in the rate of interest, if the rate of interest is 10%? This should be if the rate of interest is 10%. So how much money should I set aside? So you just write down $100,000 is the stream of cash flows you want each year, divided by R. If the average interest rate is 10%, then you got to set aside $1 million now. Remember here that your perpetuity is a special form of annuity where the number of periods your cash is received is infinity or infinity. It is not T. So perpetuity is a special kind of an annuity where the time period is not fixed. It is infinite. So remember that, okay? But they follow the same principle. So when you condense the annuity formula, the present value of an annuity, if you keep receiving that same amount, will be the cash flow times 1 divided by R, 1 discounted by R, and that comes when you solve for the formulas. 1 divided by R minus 1 divided by R times 1 plus R to the power T. This is the present value of an annuity formula. So if you want the discount factor for an annuity, then it will be calculated as not 1 over 1 plus R to the power T, or 1 by R minus 1 by R times 1 plus R to the power T. And mathematically, you can just juggle with them and you'll come down with these formulas. So once again, it is available to you in a table format, financial calculators, because financial calculators you can do, there are different kinds of financial calculators. So you have to know your financial calculator, honestly. I gave you some basic things on how to use financial calculators, but once again, they are different for different financial calculators. So please be familiar with your financial calculator. But I rely more on Excel. Excel is very much more convenient for lots of things. If you're doing bulk items. So these are the formulas, and once again, they are the tables, the discount factors and the present value and future value factors are available in annuity table. You will see a file present value of annuity, just like you found the present value table, $1, future value of $1, like that for annuity also you'll have tables readily solved. Okay. So here is an example of an annuity. You are receiving $8,000 at the end of year 1, year 2, and year 3. So you are scheduled to make 3 annual installments. You're purchasing a car. You are scheduled to make 3 annual installments of $8,000 per year, given a rate of interest of 10%. What is the price you are paying for the car today? What is the present value of that? So again, you take the $8,000, you discount it, from year 2 and 3. So discount it to today's dollars, year times 0. First year you discount by 1.1, second year discount by 1.1 power 2, third year discount like this, and then you add them all up. So today, in today's dollars, you are paying not $24,000, but $19,894.82. A nice thing. So it helps you make realistic choices, make realistic decisions. In the same example, you are scheduled to make 3 annual installments of $8,000 per year using the annuity formula. If you use, then the present value of an annuity, if you apply this, you'll get the same answer. Okay, $8,804.82. $8,894.82. Sorry, $19,894.82. So you'll get the same answer. It's just juggling of your, the symbols, that's all. So you can use, because this is an annuity, right? Same fixed payment you're making every year. So that is why, you can use the annuity table and get there and just apply there. Now, another goal that we need to accomplish here in this chapter is the concept of effective versus annual interest rates. Now, APR, you must have heard, your interest rate is so much APR. What does APR mean? Annual percentage rate. Interest rate that is annualized using simple interest over here. So when we say, what is the APR? You will take the monthly rate times 12. That is the APR, annual percentage rate. And then the concept of effective. What is effective? Effective annual interest rate. EAR, interest rate that is annualized using compound interest, not simple interest. APR is annualized using simple interest. So just multiply times 12 and monthly rate times 12, you will get the annual rate. However, the effective annual interest rate, EAR, it's annualized using the compound interest. So your EAR equals 1 plus your monthly rate to the power t, which is the time periods for which it is annualized, minus 1. Minus 1 because you're using 1 plus this side, so you got to deduct minus 1. So you get the rate. So the EAR is the more frequent compounding period, the higher and effective annual interest rate. And we'll do some examples over here. Annual percentage rate, APR. What is the APR on a loan that charges interest at the rate of 1.4% per month? Again, it is a very simple concept. So simple interest is used here. So just multiply 12 times 1.4%. So that's 16.8% is the APR. Now, If you are given a monthly rate of 1%, you are giving monthly interest rate of 1%, what is the effective annual interest rate? Now, here we are using compound interest. And what is the APR also? You'll see the difference here. My effective annual interest rate is how much? 1 plus r to the power t minus 1, right? Which is 1.01. 1% is 0.1, my monthly rate. So to the power t, 12 months in a year. So 1.01 to the power 12 minus 1, which is 12.68%. As opposed to the 12% APR. Well, APR is 0.01 times 12, so 12%. So effective annual rate is definitely more than your APR, always. You will find that, okay? So when you're going for loans, watch out for these terms. The next concept that we need to understand is real and nominal dollars. All real interest rate and nominal interest rate. Real cash flows, nominal cash flows. The word nominal simply means that it is not adjusted for inflation. So a nominal dollar is a dollar that is not adjusted for inflation. A real dollar is a dollar that is a nominal dollar that is adjusted for inflation. That's the difference between the two. So when you adjust things for inflation, and we all know what is the definition of inflation, the rate of increase in wholesale price index or consumer price index. That is the inflation. And the nominal interest rate is the rate at which the your money invested grows, and it is not adjusted for inflation. And the real interest rate is adjusted for inflation. Rate at which the purchasing power of your investment, real purchasing power of your investment increases. So let us know the link between these two. When you take the real interest rate, you want to get the real interest rate. The link between the two is inflation, right? Nominal and real, the link is inflation. So 1 plus the real interest rate equals 1 plus nominal interest rate divided by 1 plus inflation rate. So what people do is they use an approximation formula as nominal interest rate minus inflation rate. I mean, it is an approximate thing. It's not accurate. But the accurate thing is 1 plus the real rate equals 1 plus nominal divided by 1 plus inflation. So when we go, let's apply this to an example of how to link the nominal and real interest rates. Here is one example. If the interest rate on 1-year government bonds is 12% and the inflation rate is 6%, then what is the real interest rate? So interest rate on 1-year government bonds is 12% and the inflation rate is 6%. What is the real interest rate? Just plug in the formula. 1 plus the real rate equals 1 plus nominal divided by 1 plus inflation. So you want to find out the real rate over here equals 1.12 divided by 1.06. So my real interest rate here is 5.66%. And when you use the approximation, you will see that it will come to about 6% because 12% minus 6% is 6%. This is an approximation. It is not accurate, but it gives you a rough idea. So this is how you change between real and nominal figures. Same thing with cash flows also. It will be the same thing, Another example, what is the minimum nominal rate of return that you should accept if you require 4% real rate of return? And the inflation rate is expected to average 3.5% during the investment period. So you want a 4% real rate of return. Inflation is expected at 3.5%. So what is the minimum nominal rate of return that you would accept? So once again, plug in the same formula here. 1 plus the real equals 1 plus nominal divided by 1 plus inflation. So my 1 plus real is 1.04. 1 plus nominal, I want to know the nominal, and 1 plus 0.035 is my 0.035 is my inflation rate. So I just solve for this equation and I get here my nominal interest rate is 7.64%. That will be my nominal interest rate. And my approximation, I will use real interest rate plus the inflation. We are just using plus minus. So you will see here 4% plus 0.035 is 7.35. It is approximate. It is not accurate, but it is approximate. Got it? Once again, 1 plus real equals 1 plus nominal divided by 1 plus inflation. And you got it. If you want a rough estimate, then real equals your nominal. The real rate plus the inflation rate equals your nominal rate. Or real rate equals nominal minus the inflation. That's the approximation. But remember here, your current dollars, which is nominal, current dollar cash flows must be discounted by nominal interest rate because current dollar is a nominal dollar. So current dollar cash flows will always be discounted by nominal interest rate, and usually the interest rate given is nominal interest rate, unless it is specified that this is the real interest rate. But if it is real cash flows, then they must be, that means inflation adjusted cash flows, they must be discounted by the real interest rate. So that is the story of inflation and how to adjust for inflation when we move between real and nominal dollars, real and nominal interest rate, real and nominal cash flow. My current dollar is a nominal dollar. Okay. So much so about the present value and future value concepts. And we'll stop here at this point.